No. Cinesia.
I'd like to tell you about an exciting program that UniZulu Science Centre is going to be running with support from South 32. We're calling the workshop Essential Skills for Physical Science, and initially we'll be focusing on paper 1, which is the physics paper. My name is Dr. Derek Fish. I've been director of UniZulu Science Centre for the past 30 years and have been running these workshops for the past 25 years. Content for the workshop is very carefully chosen so that it prepares the matric students in the best possible way for paper 1. A very detailed look has been taken at all the CAPS exam papers so that we can assist the students in the structure of the exam, the weighting of different sections, and a very careful look at particularly the last 3 papers. Question by question comparisons have been made so that we can look for trends and identify problem areas. Special skills are taught that will be useful right across all the questions, no matter what particular question is asked. For example, the question of graphs. Students are introduced to the idea, and then various technologies are used to make sure that they understand the different parts. State-of-the-art sensors like this temperature sensor from Pasco Scientific, donated to the Science Centre by Perth Industrials, allows experiments to be done in real time with data displayed immediately in graph form and table form, allowing students a really exciting way of exploring graphs with the sensor in hot water and then placed in iced water. Where experiments can't easily be done, computer simulations again allow data to be collected, graphs to be drawn and analyzed, and conclusions to be done. Colorful diagrams and animations allow us to highlight the special skills which are important to students. Care is taken to make sure that things that can be abstract like graphs are brought home and explained in terms of how they impact our everyday lives. All of these skills are brought to bear on exam questions, and the skills required to do well in the matric exams are carefully displayed. Problem questions from previous years where students scored badly nationally are carefully analyzed to make sure that matric students understand how to proceed. The mathematical side of graphs is very carefully analyzed, and once again, this is applied to questions in the matric paper. Careful summaries are made, putting material in a way which is easy to understand and easy to follow. Where useful, acronyms like TALSIP for constructing a graph and progress for problem solving are presented to students and will be available in their booklets after the videos are finished. PHET simulations are used, which really assist the students in understanding complex tasks. Straight line graphs become easy to understand when this simulation allows students to try lots of different possibilities and to see what happens with straight line graphs under different conditions. Even includes games which the students can try and discover just how much they learn and how much they know about these graphs. Actual experiments will be conducted with data displayed on screen, allowing students to participate in data collection, graph drawing, and analysis. Where the experiments can't easily be done, again, simulations like this one from PHET will be used. All the details of the photoelectric effect and the graphs that come from it can be seen very nicely through the simulation from PHET. Real-life applications of the photoelectric effect, like solar-powered cars and NASA's solar-powered aeroplane, will be discussed and presented. All of this is done in a fun, humorous way that keeps students interested and keeps things fun. These workshops have been presented to over 200,000 students all over northern KZN for the last 25 years. Many of these students have gone on to graduate and be part of the sciences. These students had realized that facts fade, experiments expire, but skills stick. And this is why we built this program around 4 essential skills: graphs, free body diagrams, solving equations, and multiple choice and ratio questions. The section on graphs is expanded to include 4 examples of straight line graphs, motion graphs, photoelectric effect, Ohm's law, and internal resistance. All these experiments are performed and the graphs are analyzed carefully. Once again, a comment from the examiner that a severe lack of skills rather than content is evident. Looking at the November 2020 exam paper, we came to the conclusion that 64% of the long questions involve solving equations. So we've greatly expanded the equation section of essential skills to include separate sections for the equations in each of these different subject areas, covering all 9 of the long questions in the matric physics exam. We're very excited about the 2021 contents, which involves 50% more than the 2020. Also, we've taken the November 2020 exams and included them in the analysis, so the last 3 exam papers are put side by side and analyzed, and the trends are studied. We don't only answer the exam questions with the theory and the equations from the data sheets, but where possible, recreate the exam questions in simulations so that the theoretical answers can be compared with experimental answers to make it all a lot more real and understandable. Also, a lot more simulations and animations have been added. For example, this one for photoelectric effect, and comparisons done using the simulations to make the science more understandable. So we're very excited about Essential Skills 2021. The new booklet is 72 pages long and covers all of these essential areas. Not only physics will be covered. We've just finished a series of life science videos. We're working on chemistry and will then turn our attention to algebra and geometry. In addition to South 32, the South African Institute of Physics has come on board and have printed an extra 20,000 booklets. In all, 2 million pages printed this year, so that the project can go much further than just northern KwaZulu-Natal. So remember, facts fade, experiments expire, but skills stick. Please help us to make it work by using essential skills in every possible way in your school.
Hello, Itumeneng. How are you?
I'm good, thanks. And
Great. Thank you so much for joining us.
now,
Why is the study of science so important?
study of science is important. Let me speak directly to physics. Physics is vast, and there's a lot to learn in physics. There's a lot to learn in a sense that you wouldn't know if you're just sitting out there not doing anything, just reading and doing like reading can make you realize a lot of things, especially with physics. Like myself, I didn't know about this resistive switching memories up until Dr. Dlamini from the Central University of Technology introduced this to me, and then it caught my attention and say, yeah, with all the challenges that comes with it, I just felt like, you know what, I'm up for the challenge. Let's go, let's do it.
Let's do it. All right. So I know that there's a lot of young people who are in high school who are quite skeptical about venturing into careers that have to do with physics specifically. What advice would you give to such a young person?
I will speak to say, not giving up. I was in high school at some time, and they wouldn't believe me when I say I did fail physics and maths. I did get 0 at some point.
Seriously?
I failed grade 10 3 times.
But look at you now.
Now I'm doing PhD. Looking back, it's like it never happened. So yeah, not giving up. Just like have the intention, the dedication to do what you want to do, what you have to do.
And of course, resilience,
Yes.
perseverance
Yes.
becomes very important.
Yeah.
Just like yourself, I am a product of SMU, Sefako Mahato Health Sciences University. And I think that being in such an institution where you are exposed to different people from different walks of life, and eventually when you go into the science stream, the physics stream specifically, then you start to see just how these concepts can be applicable in our daily lives. just really makes you fall deeper and deeper in love with the subject itself. Was that for you as well?
Yeah, it was the same for me. Like I said, somewhere, somehow I did get some zeros there.
Yeah.
But then through dedication and, coming from where I come from, and you are at this side, you've made it to university. Somewhere, somehow, winning is the only option. You have to win, like it or not. You going back to where you come from, you're just going back to that life of drugs and whatnot, and that's not an option, I guess. So winning was the only option coming this side.
So we are in June right now, and learners are writing their June examinations. So to those who are writing physical sciences, what words of encouragement would you like to share with them?
I think study before, like you prepare, like you always prepare yourself to writing. You can be a genius whatsoever, but then if you're not studying, preparing for your exams, I don't think somehow you're bound to fail. So preparing for your exams in time and making sure you consult your teachers and whatnot, I think you'll get there eventually.
You know what they say, if you fail to plan, you plan to fail.
Yes.
So study and be prepared. And there's no need for them to be anxious or nervous. I mean, if you could fail grade 10 three times, and now in 2025, you are a PhD student in physics, anything is possible.
And I'm a lecturer, by the way.
And
I'm a part-time lecturer at the physics department.
Listen to that. Listen to that. Thank you so much. Really appreciate it. What's the future looking like?
The future is looking to resistive switching memories. I think, the future just looks bright. I think it's going to do wonders in the future. And I'm just looking forward to that. Also, in the academic area, I think so far so good. Lecturing is going well. And I think, everything about the future just looks bright.
Okay, thank you so much. All right, ladies and gentlemen, my name is Mukosi Mashela. It's a wrap. Thank you so much for indulging us in our conversations. Until the next one, bye.
I'm Jade Morano. Ever since I was younger, I would gaze at the stars with my late grandmother, and from there on, I've had this deeply rooted passion to understand the universe I would look at all the time. It enables me to one day come up with an innovative idea or discover something that could benefit our society and help us grow scientifically. Honestly, every topic involving the stars and astronomy really excites me since it's very much up my alley. I aspire to become a theoretical physicist, so mathematics and physical sciences are fundamental subjects required to pursue my career. Physics can be challenging, but very rewarding, so always test your limitations and surprise yourself. I think that physics is seen as a male-dominated industry, so I would like to flip that perspective and challenge all young women out there to believe in yourself and to really test your limits and see how far you can go in physics to change this perspective. Yeah.
My name is Tamaga Madiga. Having the passion to acquire incredible knowledge, as physics is that one subject that defines life as we know it. Having to do calculations and learning knowledge that's beyond every other subject, like geography or history. Physics is just that one excellent subject. Everything with physics in general, especially calculations, makes me want to learn more, as physics can prove life as we know it. I'd like to become an airline pilot, and physics in the aviation sector will help understand aerodynamics, including lift, drag, or airflow, which will help engineers design aircrafts and the technologies. If you love it, it will be excellent for you. Physics, when you learn physics, you step into a different dimension. So do it with passion, do it with love.
Physical science is very bad, then it means the whole science, engineering, and technology is bad. And we also call it the physics of today is the technology of tomorrow. I think those of you who have been listening to the news, you heard that the Nobel Prize for this year was given to the people in physics who invented AI. I think most of you are using AI, Snapchat, and so forth, but that's from physical science. So maybe next time it will be one of you discovering that. And here is a lot of the areas in which physical science people work.
So think about the physics. If they're saying be in the kitchen, make use of that kitchen to be a genius. Brian has said what a genius is. So I am saying you are all geniuses. You are all going to make it. What I want to tell you is believe in yourself. You are going to make it. You can do it.
Which topic is difficult? Which do you think is difficult? Yes, work energy and power. You know why you say it's difficult? You say it's difficult because when they ask you and say use energy principle, you don't know which one to use. And the heating on the surface of this metal, and then if the frequency is of high enough energy, we are going to have what? Electrons ejected there. And you can even see that with these ones here, where are the electrons themselves? Because they are going to be ejected with different velocities, depending on where the electron was. Let's say the electron was somewhere here. Here, it's there. It means that the light will come down to there, impinge on that electron, and then the electron will go that way, assuming that there are no collisions at all. And then if there are collisions, it's going to reduce the kinetic energy of that, and then it will dash off. Okay, and then this one. Right, can you give me the answers now? I think you are now fine. I don't know whether you are all right. Or, but Ara, which one? Oh, sorry. Who said that? You. Tell me, which Ara? The small R, yes.
You say rice, A plus B is C. Initially, I have X of that, which is this one here, and nothing of it. Remember? Now the change comes. This is decreasing. You see that? I will have my minus T and a minus T, And in the meantime, this is starting to increase. Hence, I have my plus C. And then at equilibrium, this is the end of your reaction. Nothing happens anymore. You are now on this block or portion. This is the equilibrium that you have here. Right. Hey, I'm not going to complete this one. You can leave it there for now.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Good morning, grade 12 learners, and welcome to the South African Institute of Physics, Physical Science, June exam preparation workshop. We will be dealing with paper 1, that is physics. You will be guided through this session by Dr. Paul Molefe from the physics department at the University of Johannesburg, and Mr. Ali Letswalo from the physics department at the University of Limpopo. Before we start, make sure that you have the following with you: a pen or a pencil, because you are going to write a lot, a calculator, formula sheet, notebook or a pad, and a focused mindset, ready to learn. Remember, if you have any question, type it in the chat box, and we will attend to the questions during question and answer session. This is a working session. That is, we'll go through this, some of the activities together. You'll be expected to write and to respond, and let's make the most of it. Welcome. Now, the physics paper 1 is structured in this way. We have mechanics, where we will deal with Newton's laws, vertical projectile motion, work, energy and power, and momentum. That constitute the mechanics part. And in this workshop, we are going to look at vertical projectile motion and momentum. You also have the section on waves, sound, and light. And the sections are broken down into the Doppler effect and photoelectric effect. And in this workshop, we'll deal with Doppler effect. And of course, there is electricity and magnetism that you'll be writing on in June, where you'll be expected to answer questions on electrodynamics and electric circuits. Now, what you are expected to master in this paper is that you must master the concepts, you must master the applications and know the applications, you must master the calculations and graphs. So the whole paper consists of those 4 key points: concepts, calculations, applications, and graphs. And we will go through this in this particular workshop. When it comes to concepts, there are certain things that you must state. For example, you'll be expected to state what Doppler effect is. You'll be expected to state what Newton's second law is. You will be expected to state what the principle of conservation of linear momentum is. So these are the things that you must read, understand, and be able to put them down on paper. You are also expected to define things. You are expected to define what the threshold frequency is in photoelectric effect, to define what the work function is in photoelectric effect, to define the free fall, and to define momentum, and to define impulse. And there are things that you are expected to be able to explain. The concept that you are expected to be able to explain include the Doppler effect. You must be able to explain what it is. Effects of current and frequency on photoelectric effect, atomic spectra, we are expected to explain that. We are expected to explain what a projectile is. We are expected to explain what isolated system is, what internal and external forces are. And lastly, in terms of concepts, in the coming exam, we are expected to describe the applications of Doppler effect, the applications of photoelectric effect, the vector nature of momentum. We are expected to describe what is elastic and inelastic collision. So that is the general, what you need to know, and consult your study guide, consult your books, and make sure that you know those aspects. Let's start with the first topic. Our first topic is...
Mr. Etsolo, can I interject there? Can you go to the slide mode?
Oh, okay, thank you. Thank you very much, Doctor.
Welcome.
Right, now our first topic is on wave, sound, and light. Remember, a wave is a disturbance, something must vibrate. And in this case, we look at matter vibrating, creating sound waves. Charges vibrating, creating magnetic and electric field, in the process creating light waves. So we are going to talk about light wave and sound wave. Remember from the previous work, you indicated or you represented the wave as a sine curve. So mechanical wave, which is sound wave in this case, will be represented by a sine curve like that. And light will be represented by 2 sine curves perpendicular to one another, which are the 2 fields. Now, just to take you back a little bit and remind you of the quantities of waves. Do you still remember what frequency is and what wavelength is and what amplitude is? Remember the structure that we use to represent the wavelength, the amplitude, and the frequency being the number of vibrations per second. So that those quantities are very important for us to study Doppler effect and photoelectric effect. Just remember that we have frequency, we have got wavelength, and we have got amplitude as the quantities associated with our sound and light wave. Let's look at sound. The frequency of sound is proportional to the pitch. That means the higher the frequency, the higher the pitch. Now, you need to be able to visualize high frequency and low frequency from the representation. Now, if you look at this red sound wave here compared to the bluish one here, you see that the frequency here, the number of vibrations are packed together. The frequency is higher compared to the blue one. And if you look at the frequency of sound produced by a thunder, it has a long wavelength as compared to that produced by a mouse. Because thunder will say, which is a low pitch, whereas a mouse will say, which is high pitch. So the higher the pitch, the higher the frequency, the lower the pitch, the lower the frequency. Now, the relationship between the frequency and the wavelength and the speed is given by this equation here, V equals to lambda F. It is given in your data sheet. Now, if you make lambda the subject of the formula from V equals to lambda F, you'll get lambda equals to V over F, which means lambda and F are inversely proportional. The higher the frequency, the higher the frequency, the shorter the wavelength. The lower the frequency, the longer the wavelength. So that relationship is very important because that is what we are going to use as we study the rest of the material. In the case of light, the speed of light is represented by a small letter c, whereas in the case of sound is represented by small letter v. Please don't use them interchangeably because they mean two different things. The speed of light is given by c, which is the same as 3 times 10 to the 8th power. It should be the 8th power there. And whereas the speed of sound will be given, it's not a constant. It depends whether the air is hot or is cold. It depends on various factors. So you'll be given the V, or you'll be expected to calculate the V, whereas the C is constant. But please don't use the speed of sound when you calculate frequency and wavelength of light, or use the speed of light when you calculate frequency and wavelength of sound. Don't use them interchangeably. When it comes to light wave, the frequency is related to color. Remember, with sound is related to the pitch, but with light is related to color. So red light will have low frequency, actually the lowest frequency, whereas blue light will have the highest frequency, or one of the highest frequencies. Okay, let's do an activity just to see if we are together on this one.
Bro Ali?
Doctor?
Can you go back to the previous slide quickly, just to help the learners with something quickly?
Thank you.
Yeah, there's a typo with the constant c. That is c equals to 3 times 10 to the power 8 meters per second. Just to clarify that to learners.
Thank you, Doctor.
Welcome.
Let's quickly do this one in less than 1 minute. Look at wave A, B, and C and compare the wavelength, the frequency, the amplitude, and the speed quickly with A, B, and C. Or let me put it this way. Which one will have the highest, which one represent the highest frequency? Is it A, B, or C? The one that represent the highest frequency. No. The one that represent the lowest frequency. A, B, or C. What do you say about the amplitude of A, B, and C? Okay, I guess you have noted them down. Activity number 1, noted it down. If your answer is that C has the highest frequency, you got it right.
And again, Dr.
Yes.
Can we maybe ask the learners to give their answers on the chat as you ask them the questions so that you can see if they've got answers correct?
Oh, yes.
Learners, could you please answer on the chat to give us the correct answers? Thank you.
Highest frequency, lowest frequency, represented by those graphs. Which one represents the highest frequency? Which one represents the lowest frequency? The longest amplitude and the shortest amplitude. Let's just take those 4. Highest frequency, lowest frequency, longest wavelength, shortest wavelength. So those 4 questions. Put them on the chart so that we can see. Okay. I see there are quite a number of responses there. Yes, indeed, the highest frequency is C, and the lowest frequency is A. The longest wavelength is A, and the shortest wavelength is, the shortest wavelength will be C. Okay.
That's all again. To interject there. Learners, please make sure that you answer the question that has been asked. And this relates more to how you guys lose marks. You asked which one represents the highest frequency. And I see there are people that are giving us A as the lowest frequency. That's not what the question is all about. Try to answer the question so that you can get your marks as the question is stipulated. Thank you.
Beautiful, beautiful. Thanks, Doctor. Okay, let's go to another one. Okay, I'll quickly go over to this one. What happens to the pitch of sound when the frequency of sound increases? Please answer, write it down on your notebook. Activity 2A. What happens to the pitch of sound when the frequency of sound increases? And B, what happens to the pitch of sound when the wavelength of sound increases? We want to see that relationship. Because when we understand this relationship, we will be able to answer the Doppler effect questions. Going, gone. Noted? No. I just want to check. Okay, I guess you have noted it in your book. Now, this is what will happen. The pitch of sound will increase when the frequency increases, because the frequency is directly proportional to the pitch. And the pitch of sound will increase or decrease. The pitch of sound will decrease when the wavelength increases. Remember, the wavelength is inversely proportional to the pitch. and the frequency is directly proportional to the pitch. This is very important to remember, learners, as this describe what the Doppler effect is all about. So remember those relationships about frequency and the pitch, wavelength and the pitch. The next one, which of these represents sound of the highest pitch? 1, 2, 3. In your notebook, activity number 3, answer this one. Which one of these represents sound of the highest pitch? Note it in your notebook pad so that we can compare the answers and make sure that you understand these relationships. Right. Check your answer. If your answer is number 3, yes, indeed, the frequency is high there. So which of these will represent the highest pitch? So number 3 will represent the highest pitch, and number 1 will represent the lowest pitch. Now, if this was light, waves, which one will represent red light and which one will represent blue light? That's activity number 4. I want you to write in your script which one will represent the red light and which one will represent the blue light from 1, 2, and 3. Record that on your pad, and the red light will be number 1 and the blue light will be number 3. Why? Red has the longest wavelength or the lowest frequency. Blue, the the highest frequency and the shortest wavelength. Thanks very much. The number 1 is red and number 3 is blue. Now, activity number 5. What is the wavelength? Sometimes you are given the frequency and you want to determine the wavelength. What will be the wavelength of sound wave if the frequency is 1,000 Hz and the speed of sound is given as 340 meters? I want you to determine the wavelength if the speed is 340 given and the frequency is 1,000. It's a very short calculation, and I also want you to do the next calculation. If you are given frequency of light in this case, if you are given the wavelength and you want to determine the frequency, can you determine that frequency if you know the wavelength and the speed of light? And Dr. Paul, Doctor?
Yes, I'm here.
How important is it that the learners understand how to use the formula, substitute, and make the subject of the formula?
Okay, I think because the learners will have the what do they call it, this information sheet. That's where they'll be able to pick up the correct formula, like you alluded earlier, that they will have V equals to lambda times the frequency. That is going to enable them to answer the first question. But before they substitute, they must actually use their grade 9 mathematics to then make lambda the subject of the formula, which is going to give them lambda equals to V over F. And the same thing with number 2, where they are supposed to calculate the frequency. They were given C to be equals to lambda multiplied by F, and they must make the frequency the subject of the formula. And this makes life much easier, and especially if you're also going to use your units, which I know that is emphasized from our schools that they don't have to use the units, but I'll urge them to try use the units and see if those units are not going to give them the correct intended units of what they know they're going to calculate. I think I've helped answering that question, Mr. Altsolo.
Very much. So what Dr. Paul was saying is that you are given the formula, write it exactly as it is given. Then you can make the subject of the formula and make your substitutions and get your answer. So he was stressing the importance of making sure that you use the right formula and you make the right subject of the formula. So that will be your lambda there. Again, you use the correct formula. For light, you cannot use V equals to lambda F. You must use C equals to lambda F, making F the subject of the formula. And here there is somehow the exponent fell down. It's 108. It's supposed to be 3 times 10 to the 8th. Apologies about that. And then you get your answer. Okay, so that is how, in some instances, you will be given lambda, but the formula needs F, it needs frequency. So this is how you must convert your lambdas into frequencies and frequencies into lambdas. Okay, now that we have done the background, let's go into the Doppler effect. Doppler effect is the change in frequency or wavelength. Remember, when frequency changes, the wavelength changes, of sound or light. It can be change in frequency of sound or change in frequency of light wave, as observed by someone. And we normally refer to that person as an observer or a listener who is moving relative to the stationary source of the wave. If, for example, we are talking about sound, something says, "Beep," that will be the source. Now, that source produces sound of certain frequency. Now, this listener or the observer might be stationary or might be moving with respect to the source, or the source might be moving with respect to the listener. One of them could be moving, not both of them. So this, when one of these, either the source or the listener, moves, the frequency will change or the wavelength will change. Remember, when the frequency changes, the wavelength changes. For example, let's look at the diagrams below. We have got this red car is stationary, and this gentleman here is also stationary. The red car produces sound in all directions with a certain frequency. So there will not be any change in frequency until the red car moves towards the listener. Then the frequency in front of the car towards the listener is higher. You see that now the frequency, the wavelength will be shorter here. So the frequency will be high and the wavelength will be short. So there will be a change in frequency. And if the car is moving away from the listener, then you can see that the wavelength becomes, the distance between the different troughs, the wavelength becomes long and the frequency becomes low. So this change in frequency when the source is in motion or when the listener is in motion is called Doppler effect. If it is light and the source of light, say the star or whatever luminous body, moves in front of this source of light, the frequency will be higher, like it happens with the sound. But when the frequency becomes higher, the color changes because it's light. Remember, frequency is directly proportional to the color. And behind, the wavelength becomes longer, the frequency becomes lower, then the color will change and it will be red because it's low frequency, and in front will be blue because it's high frequency. So this is what will happen in Doppler effect. So Doppler effect is that change in frequency because of that. Let's take an animation here. When this car moves forward, you see what happens to the frequency in front? It becomes higher, and behind it becomes lower, or the wavelength becomes shorter in front and longer at the back. So that is the Doppler effect. It has got many applications, and you are expected to know these applications. Doppler effect is used by traffic cops to do when they trap the fast-moving vehicles. That is that camera, which you normally refer to as camera, shoots produce frequency which hits the speeding car and is reflected from the speeding car and is detected by the camera, and the camera then take that Doppler effect, shift in frequencies, and determine the frequency of cars. It's also used to measure the speed of stars. If a star moves away from the Earth at a certain speed, it will look red because the wavelength behind will be longer. It will go into the red shift. So we are able to determine the speed of stars and galaxies. And it's also used in medicine to detect blood flow and heart condition. This is by using sound wave, which you call ultrasound, that is sound with high frequency, and we are able to determine how fast the blood is flowing in the arteries and in the veins and through the heart. So those three applications are very important. You need to know about that. Now, this Doppler effect, there is an equation associated with that, is given in your data sheet. FL equals to V plus minus VL over V plus minus VS FS. All that you have to look at here is what is the frequency as heard by the listener, that is FL, the frequency produced by the source, that is Fs. V is the speed of sound, which will be given or you'll be requested to calculate. VL is the velocity or the speed of the listener. If the listener is moving, we'll be moving with VL. Now, it's either positive or negative, and we'll talk about positive and negative right away. The Vs is the velocity or the speed of the source. Again, it can be positive or it can be negative. Now, in Doppler effect, we will be requested to use this formula. Now, let's go through and see how we can use that formula. Remember, when the source is moving towards the observer, to the listener, the frequency becomes higher. Now, if you look at the equation and we want the frequency to be higher, the FL to be higher. Remember, the frequency of the source is constant. The one that changes is the one as heard by the listener, FL. Now, if you want FL to be higher, okay, is that the question? Now, let's look at this expression, A equals to X over Y. Now, if you want A to increase, you either decrease Y or increase X. Now, in this case, the velocity or the speed of the source is below here. Now, if you want to increase FL, then we must make it negative. We must decrease. So for FL to increase because it's in front or towards the listener, the VS must be negative. And if the source is moving away, then the FL must be lower. So the VS must be positive. Because if we want A to be less, we must increase Y. So we make it positive. If we want to make A to be more, we must decrease Y. That's why VS is negative. So you check whether you want the FL to be higher or lower, and then you use you make VS negative if you want FL to be higher, and VS positive if you want FL to be lower. When is FL higher? When the source moves towards the listener. When is VL lower? When the source moves away from the listener. So that is how we choose the positive or the negative, depending on whether we want FL to be higher or FL to be lower. I hope you understand, learners, that VS will be negative if we want FL to be higher, and it will be positive when FL is lower. Towards the source, towards the listener, VS will be negative because we want FL to be higher. Away from the listener will be positive because we want FL to be lower. Okay, let's make an exercise. But before we do that, look at what will be given on the data sheet. You are given the formula in English and in Afrikaans. Use the English version, and please don't use the other things, the E equals to HC over lambda. Don't use that. That is for something else. That is for photoelectric effect. Just use that equation. In your study guide, they give you a guidance saying that the VL is positive when the listener is towards the source, negative when the listener is away from the source. When the source is going away, the VS is positive. When the source going towards the VS is negative. Exactly what I've been talking about, just summarized there. All you need to do I want FL to increase? Then VS will be negative and VL will be positive. Okay, that is just a summary. And again, just give you a summary of that equation. Source moving towards the listener, you see that your VS is negative. Source, listener moving towards the source, the VL is positive. Source moving away from the listener, you just check when do you want your FL to be more or to be less. Just a quick one. Now, a source of sound approach approaches, that means going towards a stationary observer at a constant velocity. Which of the following describe how the observer frequency and wavelength differ from that of the source? Remember, the source, the frequency of the source does not change. What changes is the frequency of the listener. Now, if the source is moving towards the observer, what will happen to the wavelength and the frequency compared to that of the source? Will the frequency, will the wavelength be greater than that of the source and the frequency greater than that of the source, or less than that of the source? That is the wavelength and the frequency less than that of the source, or will it be greater than that of the source or less than that of the source? Look at it and think about it. The source is moving towards the listener. So what happens to the frequency and what happens to the wavelength? Will it be more or will it be less? Will it be greater or will it be less? That is the frequency. And what about the wavelength? Just as a tip, remember, when the wavelength increases, the frequency decreases. So somebody says B will be the correct one. What do you say? Is approaching, is going towards, so the frequency will change. And we said it will increase or decrease. The right answer will be number D. The wavelength will be less because the frequency is increasing. Remember, the wavelength decreases because the frequency is increasing when it is going towards. Going towards the listener, the frequency increases, the wavelength decreases. Okay.
Let's go back to that slide again. Thank you.
Yes.
I think one of the things that the learners must be aware of is that answering a question like this one, they need to be able to eliminate the incorrect answers so that they remain with less options to choose from, and that is going to enable them to get the correct answer. And the other thing is to go back to the diagrams that we have shown before of you know, the source have been backward. Yes, to go to this again to help them out to get the correct answer. So in every answer that you are trying to get, especially on the multiple choice questions, try by all means to eliminate. And if you're able to eliminate, it's because you'll be having the reasons that you are giving behind that elimination. And that will help you to get the correct answer, especially when you're dealing with multiple choice questions. Thank you, Ndatele Tsolo.
Thank you, Doctor. Okay, you got it. Now, I want us to do this one. An ambulance is moving away. It is moving away from a stationary listener. That means the listener is not moving. And is moving away with velocity 25 meters per second. Now, this ambulance siren emits frequency of 550 Hz. The listener detects the frequency, that is what the listener hears, of 512.64 Hz. Now, I want us to use that formula, but we need to indicate what is FL, FS, VS, and VL. I want you to quickly identify the data. What is our FL from this statement? What is our FS? What is our VL? What is our VS? What is our V? Can we quickly do that? Can we quickly do that? In your notepad, just read the sentence, put the value for FL, for FS, for VL, for VS, for V if it is given. That means we want to use the formula, but we need the data for the formula. Let's identify the data. I guess you are done. We have recorded activity 8 FL, FS, VS, VL, and let's compare. Did you get something like this? Frequency of the listener is 512.64. Frequency of the source is given 550. Velocity of the listener, because it's stationary, it has to be 0. And velocity of the source is that. If you got them like this, then you are correct. Remember, the listener is not moving, so the VL must be 0. The source is moving at 25 meters per second, that would be a VS. Okay. Now, if we are requested to calculate the V, the velocity of sound in air, we know all those quantities except V, then remember it's moving away. When it moves away, FL must be, the frequency must be lower. That is why the VS is positive. If you want FL to be lower, the VS has to be positive there. So you just substitute like Dr. Paul indicated that you need to get the equation, good substitution, and make the subject of the formula. Okay, that takes care of our, there are some other examples, which is another example here. Again, it is not very difficult. It's not very difficult to get whatever you need. The FL, the FS, the VL, the VS, the V, and then you substitute into your equation. The ambulance is approaching, that means it's going towards, meaning that the VS will be negative because you want FL to be higher. And this is approaching the scene of an accident. The scene is not moving, your VL will be 0. And then you just substitute accordingly. Okay. Just one, last one before we step out of this, is that this is a homework from November 2024 question paper. I just want to make you aware that you are given the wavelength of the listener and the wavelength of the source. Do you see the wavelengths? You are not given this in terms of frequencies, but the formula that we are going to use needs frequencies. Therefore, when you have a wavelength like that, you must then write it in terms of frequency and also write this in terms of frequency so that you can substitute it nicely into that equation. Remember, the equation does not have the wavelength, it has the frequencies. But if you are given the lambda L and lambda S, those lambdas must be converted into Fs and to frequencies so that you are able to solve that problem. So this is the question from our 2024 November final exam. I just want to, as a way of revising the Doppler effect, I just want you to go through that. And it's straightforward. We'll see that the Doppler effect is not a very difficult section, but you just need to know what is FL, what is FS, when it is this plus, and when is the other one negative. Okay, learners, let's take up to here the topic number 1. Please note the questions that you might be having, and we'll attend to that under question and answer. Dr. Paul?
Yeah, I just want to emphasize something from this homework question, that the learners must make sure that they practice their graphs and be able to see the integration that they have between mathematics and the physics that they're doing now. So what they've learned in mathematics in terms of graph is still applicable in the physics. So they must make sure that they take the positive stuff from the maths and utilize it in the physics so that they can be able to answer these questions that are given in the physics. Thank you, Dr. Letsolo.
Thank you, Doctor. Okay, the last one is that remember, you are expected to be able to state the Doppler effect. It's a question is coming in the coming exam. In every examination, you are expected to state the Doppler effect, and you are expected to give everyday examples. We gave you 3 examples. One of that, they will ask for one. You are also expected to describe the applications, as I've already indicated. So don't forget to make sure that you can state the Doppler effect and describe the applications, and to use that equation to calculate whatever is needed. Remember when to VL or VS is positive or negative. Okay, now with that, I want us to look in another topic number 2, vertical projectile motion. Vertical projectile motion. This is a motion either up or down, or both up and down. It's vertical, is projected, is thrown, something is thrown upwards, or sometimes we just let go downwards, which we call free fall. And it's another, not a very difficult section, but that needs a lot of care. Now, let me just run through, let us just run through the important concepts here. The first one is that here we're dealing with an object which is in a solid matter. That means we are not talking about wind or air or water and things like that. Projectile motion is about solid matter. The motion is vertical, only vertical. There's no horizontal motion. That is either up or down. So the object will be projected upwards. That means will be thrown upwards, and it will be given an initial velocity, VI. It cannot move up until or unless we give it an initial velocity. If it has to fall freely, we just let go and it falls downwards. So the initial velocity there will be 0 meters per second. Now, sometimes it can be thrown downwards or projected vertically downwards with an initial velocity VI. For example, if you have a ball and you throw it vertically downwards, that means you give it an initial velocity VI. If you just let go and let it fall freely, the initial velocity will be 0 meters per second. So with the projectile motion or free fall, there is always some initial velocity, either 0 in the case of free fall or another value. Now, the forces acting on a projectile or on this object is only the weight, nothing else. There is no other force. That's why we say ignore air resistance, because air is not solid. So there is no other force except gravitational force. May I just remind you that gravitational force is constant when we are dealing with objects near the surface of the Earth, of course, and gravitational force is always pointing downwards. Gravity never points upwards. It's always pointing downwards. If we talk about Cartesian coordinates, it points in the negative y direction, always. And then remember, this weight or this force is m multiplied by g, where m is the mass, is a scalar quantity. So the direction is the direction of g. And this motion has some quantities, 5 quantities: displacement y, the initial velocity vi, the final velocity vf, gravitational acceleration g, and the time t. Remember, at the maximum height, vf is 0 meters per second. It will go up and stops and comes down. vf is 0 meters per second. In all cases, the acceleration is g. So having those 5 quantities, we also have 4 equations that we can use to determine whatever we need to know about this motion. Equation number 1, 2, 3, and 4. And please note that these equations are not given on the data sheet. They are given on the X along the horizontal. You just make, wherever you see X, you make Y. Wherever you see A, you represent it by G. So we have got 4 equations, learners, only 4 equations. And each equation has 4 known quantities and 1 unknown quantity. So that means you need to use them. You need to know 3 quantities so that you can solve for the 4th. Always make sure that you have the 3 quantities, then you choose the right equation to solve for the 4th. What you are expected in this topic is that you must be able to use these equations to solve for unknown quantities, and also to use the graphs to explain these quantities. So we are going to use equations and we are going to use graphs to explain this motion. It can be dropped from a certain height, and it can be projected upwards and it comes back to the same level, or projected upwards and goes below the level it was projected from, or it can be bouncing. So in all these cases, we are quickly going to use the equations and use the graphs. Remember, in this topic, you will be expected to use the equations and to use the graphs. Now, let's see how we should use the equations and let's see how we should use the graphs. You need to be able to define free fall. Please make sure that you know how to define free fall and to explain projectile motion. Is there in the test. It's always there. So if a projectile is when an object which has been given an initial velocity and then it moves under the influence of gravitational force only. Remember, the other word for gravitational force is weight. And the free fall is a motion during which the only force acting on an object is the gravitational force. These two, this definition and explanation is very important. Please make sure that you write it down. Don't read it and think you'll be able to produce it. Write it down. Definition of free fall. You write it down. Explaining what the projectile motion is. Write it down. If you write it down, you'll be able to reproduce it in the exam. Okay. That was the first activity. Just make sure that you are familiar with that. Now, how do we use these equations? Like I indicated, there are 4 equations. You write down the data. You must at least have 3 data and check the directions. Take up as positive, down as negative, unless otherwise indicated. If they don't indicate, take up as positive, down as negative, because that is according to the standards. Cartesian coordinates is up positive, down negative. The standard of physics is like that. But if they say the other way around, fine, do it the other way around. So those are the 4 equations. Get the directions. You select 1 out of the 4. There will only be 1 suitable equation out of the 4 for a given question. Simple example. Look at this boy. He's jumping vertically upwards from the trampoline with an initial velocity of 30 meters per second. Initial 30 meters per second going up, and he will come back because the only force acting on this person is gravitational force. Now, calculate how high will this boy go. What do? Record your data. Sometimes I prefer a table because it gives you a better visual of your data. Remember, there are 5 quantities: is delta Y, VI, VF, G, and T. You look at the question. The question says 30 meters per second up. Let's take up to be positive. There is our 30 meters per second. And they talk about what will be, how high will he go? That means at the maximum height, 0 meters per second will be our velocity. And we know that is under the influence of gravitational force. That means it accelerates at G. G is pointing downwards, is a vector pointing downwards, so that's why we make it negative there. We have 1, 2, 3 quantities. Then we can solve for the 4th one. What are we expected to solve? How high? That is delta Y. So there will be only 1 equation out of these equations which we can use, and that is equation number 3. It has delta Y, it has VI, it has VF, and G. Doesn't have T. So we are going to use this equation. You must write it down. You get marks for choosing the right equation. Then you must substitute. You get another mark for substituting, and you make delta Y the subject of the formula. You get another mark for making delta Y the subject of the formula, and get the answer. You see how we use the equations? Always record your data for the 5 quantities. Whatever you know, you must at least have 3. Choose the right equation, substitute, solve, make whatever you need the subject of the formula, and you have all your marks. That's how we use the equations. Let's take an example. Doctor.
Yeah, thank you. On this one again, I just want to emphasize something that I've posted on the chat.
Yes.
From this example, If you look at the table that is given there, you've got your initial velocity being positive, and you've got a g being negative. As this boy is projected upward, as he jumps upward, his speed slows down until it gets to his maximum height, with that final velocity being equals to 0. That's how one way that you can interpret this projectile motion using the equations. And you can actually see that when this guy comes back, your velocity will be in the same direction as the gravitational acceleration. That will mean this person is speeding up as it goes down.
Yes.
So that is also very important. And again, to go back to the delta y, please go back and study your grade 9 maths, where you are taught how to make delta y the subject of the formula from this equation 3. If you're able to do this, life becomes so easy when you substitute, because whatever that you're going to plug in there and the units will give you the correct units that you are looking for without guessing that a delta y is going to be in meters. Thank you, Ntatelo Tswalo.
Thank you, doctor. You got it. You got letters. It's very, very, what doctor is saying is crucial. You need to say, oh, the velocity is decreasing until it gets to 0 meters. And from there, it's increasing, but now in the negative direction. We say positive up, negative down in this case. Like I said, if you are not told otherwise, take positive up, negative down. Okay, let's do this one quickly. Let's do this one quickly and see if we can replicate that. Is the same boy is jumping vertically upwards from a trampoline with an initial velocity, the same situation, but now we want to determine how long will it take him to return to the trampoline mat. He goes up, then down to the same level. Now, record the given data and the implied data. In the table there, you must at least have 3 of them. Remember, we are talking, the question is about when will he be on the mat? Not up there, but on the mat. He leaves the mat with initial velocity of 30 meters per second. When will he be in the mat? And when is the time? I want us to record the data in that table and choose the right equation. Let me give you minutes to do that. Hello. Yeah. Recorded. Just wanted to, don't make calculations yet. We just want you to record the data and choose the equation. I guess you are done. Let's have a look. Did you get that? Delta y, 0 meters. He left the mat, went up, positive displacement, came down, negative displacement. He started from where he ended from where he started, so the delta y will be 0 meters. That is, the displacement will be 0, and vi is given 30 meters per second. G is known. This is projectile motion, negative 9.8 meters per second. And we want to determine time. So we have three quantities, 1, 2, 3 quantities. We need the fourth one. There will be an equation with those three quantities and the fourth one that we are interested in. And that will be question number 1. I guess everybody got that. That the VI and the G are given delta Y is the displacement. If I end where I started, my displacement will be 0 meters. Okay.
Again, Dr. Letswalo,
Doctor.
There's a question here. Somebody says I've used equation number 2.
Yes.
And the question then will be, would I be wrong to use equation number 2 in this particular equation? I mean, question.
Well, we don't have VF. We don't have VF from the given data. We are given VI. We know G, and we were able to know delta. We don't have VF. The final velocity at the met. Of course, by symmetry, if VI is 30 meters per second on the met, when it falls, VF will be negative 30 meters per second by symmetry. In that case, yes, we can use number 2. You can use number 2, where your VF will be negative 30 meters per second. Isn't it this thing goes up and then it stops and it comes down? The time to go up is the same as the time to come down. The velocity with which it started is the same as the velocity with which it will end at the same level. So yes, in that case, number 2 will work, provided VF is negative 30 meters per second by symmetry.
Thanks, Dr. Letswalo. I think the other way of answering that is, or rather why the student took that route is because there was an activity 1 that led to the final velocity being 0. So I think for the student to be able to choose that one, they need to be able to justify. If this was the only question, it will be difficult to justify why VF is equals to 0. But if you follow what Mr. Letswalo was saying, of putting your data in your table is going to enable you to come up with answering the question, because it also says in this question, determine how long will it take him to return to the trampoline mat. So that is also giving you a direction that your delta Y is going to be equals to 0, but it's not giving you the turning point. So that will be an extra mile that you can actually make mistakes with in other questions, but try to make it as simple as possible for yourselves to be able to answer the questions. Thank you, Dr. Letswalo, for that.
Thank you. Okay, another one is from last year's paper. Let's just use the equations again. We are just learning how to use the equations because you are requested to use the equations. Actually, even in the question, they say use only equations of motion. Do you see the statement there? They want you to don't use the graph for anything else. Now, it says a ball of mass of a certain mass is thrown vertically upwards from the top edge of a building, which is 15.3 meters high. The ball reaches a maximum height of so much above the top of the building. And then don't worry about the rest of the thing there. We'll talk about it later. Just up to top of the building. I want you to record the data. We want you to record the data, the given and implied data, take up as positive, and again choose the suitable equation. Just by going up, while it will come down, here, the question is, the ball strikes the ground and bounds vertically upwards, reaching a maximum. Okay, no, don't worry. I want you to record this data for me. What is your VI? What is our VF? What is our G? What is our T? Just going up and back to the, let's say back to the bottom. It goes up until it reaches the ground at the bottom. Don't worry about the bouncing. Look at it as it goes up and back until it reaches the ground down there. What will be our delta Y? What will be our VI? What will be our VF? What will be our G? And what will be our T? For this ball to move up and now hit the ground. Up and it hits the ground. I'm giving you 2 minutes. Again, the ball goes up and come back until it hits the ground. Don't worry about the bouncing, just until it hits the ground. Let's see if we can be able to determine our VI, our VF, our G, our T from what is given. Okay, what is our delta Y? It moves from the top of the building, it went right up, and then it came right down, past where it was, and then hit the ground. What will be our delta Y? Anyone who got delta Y to be 5.89? 0 meters or negative 15.3 meters. Our delta Y will be negative 15.3 meters. This is how it happens. Remember, it starts at the top, it went up. It went up there, and when it came down, it's negative 5.89. Positive 5.89 is up. Negative 5.89 is when it comes down, so it cancels out. The only thing remaining is from there all the way down there. That is why our delta Y will be negative 15.3 meters. And our initial velocity is not given here. The question is, they want us to determine that initial velocity. The final velocity is not given, but that is, we can determine it because if we know delta Y and we know G, remember G is always negative 9.8. We know delta Y, we know delta G, and by the way, we don't have the initial velocity. Yeah, I made it a little bit complicated, I see. But anyway, what is important is that in this kind of situation, just know that your delta y will be negative, the height of the building, but in the negative direction. I think the question was multi-pronged. I'll come back to it, Lenas. I'll come back to it. Let's do this one. A ball of mass 200 grams is dropped from the roof. Now this is free fall. It's dropped from the roof, which is 100 meters high. Ignore air resistance. Now, question number one, determine the velocity of the ball when it hit the ground. Question number two, how long is the ball in the air before it hit the ground? So each question must have its own table. So this is the data for question number one and data for question number two, and then we'll have equation for question number one, equation for question number two. Can we do this one? I think this one is more easy to do. Just fill in the three known quantities and the unknown one for both question number one and question number two, and choose the equation. 2 minutes. I'm still busy. I guess we are okay. Let's compare our answers with this. It's drop downwards, delta y is negative 100 meters. Remember, we take up as positive, down as negative. It's been dropped, that means VI is 0 meters per second. We don't have VF now. That is what we want to determine in question number one. We know G is negative 9.8. If we have 1, 2, 3 quantities, we can solve for the fourth one. And the equation that we'll use is V squared F equals to V squared I plus 2GAY. And then, of course, if you calculate, we'll get that answer. For question number two, how long? We want time. What do we have? Delta y, negative 10 meters, 100 meters. VI 0, G is 9.8. And you see that now we are using a different equation because of what we are given. So this is how we deal with equations of motion when it comes to free fall. So it's just make sure that you record your data, you choose the right equation, and then you solve. Record your data, choose the right equation, and solve. Be mindful of the direction, because the V and the Y and the G are vectors. You must give them directions. Okay, I think that takes care of how to use equations, learners. Quickly, let's see how to use graphs. Again, there are 3 types of graphs: position time, velocity time, acceleration time. For projectile motion, for any motion, at any given time, the position is given by that equation. So do you see that if you use mathematics, remember Dr. Paul has always been saying, refer to your mathematics. This will be a parabolic function. That's why the curve looks like that. It goes up to the maximum height and then it comes down. And then the velocity at any given time is given by this equation, which is a linear equation. That is why the shape is this red line, which is a straight line. It starts initially at VI, It went up. As it goes up, it becomes slower and slower and slower until it reaches the maximum height. You see where it cuts the time axis. That is the maximum height, and then it comes down. The velocity is constant. It doesn't change with time because g is negative 9.8 at all times. So those are the shapes of the graphs from which we can deduce the data, from which we can determine certain things. So remember, position 1 is a parabola, velocity 1 is a straight line, and the acceleration 1 is also a straight line, which is constant, which doesn't vary with time. Okay, that is the 3 graphs. And for free fall, is part of the parabola. Remember, it goes down, so the position is changing downwards in the negative direction. That's why the parabola is like that. The velocity is a straight line, and the acceleration is still the same as when it goes up. So that will be the shape of a graph for free fall. And if it is thrown downwards, it's taking the shape, the parabola like in free fall, but now the graph does not start at 0 because we give it an initial velocity in the negative direction. Remember, down is negative, up is positive. And just an activity here, you are given a graph like this. They say, from this graph, indicate what is the maximum height reached and the time taken to reach the maximum height and time taken for this projectile to come back. You remember the parabola? Parabola. So the maximum height is the maximum position. You look at this and where is the maximum position? The maximum position is at 19.6 meters. So the maximum height from the graph will be, you look at the maximum point, the highest point there. So that will be your maximum height. When will it be at maximum height? Maximum height is there. Look at the time that corresponds to that. And that becomes 2 seconds. At 2 seconds is at maximum height. And when will it be back from where it was projected? It was projected from here, it went up, it came down after 4 seconds. It's back after 4 seconds. So that is how we interpret the position time graph. The maximum point will be the maximum height. The time corresponding to the maximum point will be our time to reach the maximum height, and time corresponding to when it is back at 0 position will be the time of flight. So it's quite straightforward to interpret the graphs. That is the situation. Let's take another one. Here we have velocity time graph. This moved, it started at 19.6. Do you see that the initial velocity is 19.6? It moved upwards. Look at the line as it comes like that. That means the object is moving upward until the velocity is 0. What happens when the velocity is 0? Is at maximum height. So here at 2 seconds is the maximum height. How do we go see the maximum height from the velocity time graph? Where velocity is 0, because velocity is 0 at maximum height. So at what time will that be? 2 seconds. And when will it come back to where it started? It started from maximum height. Now it increases downwards. You see the velocity is increasing downwards until that velocity is 19.6. So it will hit the ground from where it started at 19.6 meters per second. And at what time? 4 seconds. So that is how we interpret the graphs. So you must be able to say this red line is not the path followed by the projectile. is the velocity, how the velocity changes as with time. So that is how we interpret that. And when it bounces, it goes up, comes down, and it goes up again. Sometimes it will go to the same level. Sometimes it might go to a different level. We find that it goes something like that. But in this case, it went up to 81.6 meters. It came down and it went up again to 81.6 meters. It came down. When did it reach maximum height? It reached maximum height at 4.08 seconds and 12.240 seconds. The second time it was after 12 minutes, it came back at 8.16 seconds and again at 16.3. So that is how we read the graphs. Remember, we can use the equations and we can also use the graphs. Okay. Now, with the velocity, the bouncing, you see, is the same like we did previously. It started at 40 in this case. It went all the way down. It reached the maximum height in 4.0 seconds, and it went back. It bounced back to the maximum height, and it came back. So again, we can determine the time when it is at maximum height. It was at maximum height at 4.0 and at 12, because maximum height is when the velocity is 0. And then how high did the ball go? That's a good one. How high did the ball go? From this, the area below the graph is the displacement. So if we can determine the area of this rectangle, until it reaches the maximum height, we'll know how high will it go. And indeed, it's half. Remember, area of a triangle is half base times height. So it's half of this, base 4.08, half of that, times the height, which is 40. So the total, the height the ball went is 81.6 by just calculating the area below the velocity time graph. Okay, there's a exercise from last year. Just go through that and you'll see how things fall into place. The last topic before we knock off is momentum and
Dr. Letsolo. Mr. Letsolo?
Doctor.
Yes. Can I ask you to quickly go back to activity 2?
Activity 2.
Activity 2 and 3. I want us to clarify something there quickly.
Yes.
Yeah, I think it's this one. Yes. Where the student asks us whether to use the equation 2 is correct or not.
Yes.
Maybe something to emphasize there is that what would have calculated, which the answer that I see on the chat is 3.06 seconds. That is one segmental path that it has taken. It is not answering the question. So you need to multiply this by 2 to get the actual answer that was asked. That is to determine how long will it take him to return to the trampoline. But using that equation, we have actually calculated only one segment of this boy jumping upward. I wanted to clarify that one.
No, thanks, Doctor. Yes, if you want to break it into different sectors, like going up is so much time, coming down is so much time, then you'll have, you can do that, although you are not answering the question directly, but that if you just take it up to the maximum height, is part of the question. It's not the complete question. Thanks, Doctor.
Yes, the activity 3.
Activity 3, yeah.
Yeah, I think in the activity 3, you said something like you made it very tricky I just want to make them aware that it is not tricky like you thought as you're reading it. It is a straightforward question. It also needs them to be able to populate their data sheet or diagram or table so that they can be able to get exactly what they're asked to calculate. One might be tempted to take the time as part of what they'll calculate, which is the longest route to take, and you can make mistakes. But if you populate it correctly with the given data from the statement, then it's an easy question to answer because you'll go straight to the equation that you are going to choose out of the 4 that Mr. Letsolo shown you earlier on. So I just wanted to emphasize that too. And maybe the last one, it will be activity 6 and 8. Yeah, it's fine with this one. What is very important again on what Mr. Letsolo was explaining here is to look at this graph moving from 19.6 going to 0. This shows you that as you're throwing it up, it slowed down until it gave you the maximum velocity of 0. Then as it goes down, after it has momentarily been at 0 and turning down, now you see that you've got your velocity and acceleration in the negative direction, which then shows you that this object is actually speeding up. That's very important for you to see from these graphs and interpret them correctly. So that the second one, which has the bouncing ball, is easy to answer those questions that are asked because we're able to interpret these equations correctly and the diagrams. Thank you, Dr. Letsolo. I think I've summed up what you've done.
Thank you so much, Doctor. I guess, Lenas, we are together. So this one is 2024 November exam. Just go through that. It will make matters easy. Now, the last topic that we are going to do in the last minutes that we have is impulse and momentum. In this section, you are required to be able to define and describe and state. Go through your book, go through your study guide, make sure that you know how to define momentum, how to describe the momentum vector, how to state momentum, Newton's second law in terms of momentum, and how to define impulse, how to state the principle of conservation of linear momentum, and explain isolated system and distinguish between elastic and inelastic. There's a lot of conceptual understanding needed here, and please write them down one by one. I want to define momentum. Chicky on paper. I want to describe the nature. Chicky on paper. I want to state the principle. Write them down, because in this question, they are always asking these things. There are calculations, which we are going to look at now, but the important thing is these descriptions, the calculations, the explanations, the stating is very, very crucial. In the data sheet, you are given
Dr. Letsolo, going back to that slide again, thank you. Yes, I think the other thing that we need to emphasize here is that when they are asked to state Newton's law or your momentum, whatever that they're asked to do, they must just remember that they are not actually asked to duplicate what is written on the study guide, but to make sure that they understand and they've got the key words that are describing or stating whatever that they are asked. So that is very important to give them marks. Be able to make sure that the key words are there in your definition so that you can collect maximum marks. Thank you, Dr. Letsolo.
Thank you very much, Doctor. Yes, for every definition and description, just underline the important words. There are certain words that must always be there. So even if you say it in your own words, but those keywords must always and always be included. Then you have all the marks. Just to give an example, suppose they say, state Newton's first law. You can say it in any way, but the keywords will be at rest, constant velocity, constant velocity, you need to be able to determine the keywords. So in this specific topic, make sure that you are very conversant with your concepts. It's a concept-loaded topic. Of course, there are calculations, which we are quickly going to look at. And I just wanted to indicate that in your data sheet, the only thing that we are given about momentum are those two quantities, formulas that I've highlighted there. Otherwise, the rest you will have to. Otherwise, you'll have to look at the rest, develop the rest. Don't use the other. Oh, and the P equals to MV there is also important. All right, now let's go into the issues of momentum. Momentum is an inertia of a moving object. Remember, inertia, things tend to continue doing what they are doing unless an external force is acted on them. Moving objects tend to continue moving. That's why when you throw a projectile upwards, although the weight is pulling it down, but it goes up because of its momentum. It's an inertia of moving object, and we represent it by P equals to M multiply V, where M is the mass, which is the inertia, measure of inertia. But now, because it's moving, we multiply it by velocity. So that is what momentum is. Remember, a momentum is a vector quantity. It will have magnitude and direction. When something moves to the left, and it will have a negative direction. When it moves to the right, we could give it a positive direction using the Cartesian coordinate, positive x, negative x, as your basis for the direction. So the momentum can change. When does it change? When the velocity changes. You throw a projectile upwards, what happens to the velocity? The velocity decreases until it reaches the maximum height. So the momentum of a projectile will change from when it had initial velocity until the velocity is zero at the maximum height. So this change in momentum is also referred to as an impulse. So the impulse is the same as the change in momentum. And impulse is given by force multiply change in time. The net force multiplied by change in time. By the way, when you throw a projectile upwards, what is the net force on the object? Do you still remember what the net force on the object is? Yes, it is the gravitational force. It's the only force. That is the net force. So if the impulse of a projectile changes, that will be equal to the net force multiplied by the time taken for that change. That is why you can easily determine the time to reach the maximum height by using change in momentum, because change in momentum equals to F multiplied delta T. We know what F is. We can easily determine delta T. So momentum can also change during elastic and inelastic collision. So something that could also make momentum change is collisions. When things collide, velocity is always changing. So if it collide and separate, we call it elastic. It collide and stick together, we call it inelastic. So that momentum is directly proportional to mass and is also directly proportional to velocity. And we can talk about change in momentum is mvf minus mvi, the final momentum minus the initial momentum. And we can also talk about impulse, which I've already indicated. And the momentum can be written, change in momentum is F net multiplied by T. That is, I already indicated that. Now, if you want to write Newton's second law in terms of momentum, is Newton's second law says F net equals to change in momentum over change in time. So F net is delta P over delta T. So that is one of the things that said you must be able to explain or state, and voila. So momentum, its direction to the right, take it as positive unless otherwise stated. To the left, take it as negative unless otherwise stated. So there are those definitions that I talked about. We need to define impulse, the net force, the conservation of linear momentum. A system that does not experience an external force is the isolated system. Just make sure that you are conversant with them. Let's do this activity before we say goodbye. A boy of mass 30 kilograms jumps vertically upwards with an initial velocity of 20 meters per second. We want to ignore the air resistance. What is the initial momentum? Question number one. What is the change in momentum for it to reach the maximum height? And the time the boy takes to reach the maximum height. Let's use momentum P equals to mv delta P equals to mvf minus mvi and work it out. 2 minutes. Let's work on it. Okay, you can see that the initial momentum MVI will be 30 times 600 kilograms, meters per second. How did it change? Final minus initial. What is the final velocity? 0 minus initial velocity, 20 multiplied by m minus 600 kilogram meters per second. The time taken, change in momentum equals to F net delta T. We make delta T the subject of the formula, minus 600 over 30 times minus 9.8, and that will give us time. My dear grade 12 learners, let's go to question and answer session. The important thing here was to indicate that you need to understand, define those concepts, and use the equation P equals to mv to determine your momenta. And when you have collisions, according to Newton, conservation of momentum, momentum before collision equals to momentum after collision. Let's take question and answer session. Let's check on the chart and see what is there. Otherwise,
we'll go back to activity 1 as we go to the question and answer. Yeah, learners, I think we have seen here that Mr. Latswalo didn't give you the option of using the table, because the assumption is that by now, you know that when you're given a statement, you must come up with a table and populate that table with the given data so that you can actually apply it in choosing the correct equation. That method still applies here. It applies in every question that you have, whether it will be in the physics or in the chemistry. Make sure that you populate the table so that you can be able to choose the correct equation or formula. Thank you, Dr. Letsolo. We can go for question and answer questions.
Correct, Doctor. I cannot overemphasize what you said. That gives you a picture of what you are dealing with. If you have a table, then you are able to know which equation to use and so on and so on. We have this other one, but this will be your homework. Let's go to question and answer session. And Doctor, you'll assist me from that side. I don't know if I'm able to see the charts.
No, I'll be able to help. I've got access to both the YouTube and the Zoom chats. So guys, you can ask your questions, type your questions, and let's try to answer your questions or clarify where you guys got confused. If you want to take us back to a slide that we have shown, you can do that. While, or maybe because we don't have people asking questions now, we can actually talk about maybe answering the question papers in this session too, while they're thinking of the questions. Yes. One of the important questions that normally is being asked is whether you should start with the multiple choice questions or you start with long questions. The answer to that is there's no best formula of how to answer the question paper, except that if you take your time after you've been given a question paper, you study your question paper, you'll be able to identify questions that you are sure that you're going to collect the maximum marks from. And what you'll then do is you put them in a sequence that will give you the maximum marks out of that 150. Then if I'll give an advice, it will be to start with all the questions that you are sure that you're going to collect maximum marks, and you'll see that you'll be able to finish early or earlier than any other person that would have started with questions that they don't understand and struggle. And if you start with the ones that you master and you collect maximum marks, you actually play a psychological part in your mindset that will be so relaxed that even the questions that you thought you couldn't do, you'll be able to answer them with ease. And you can actually increase the percentage mark that you're going to get from the original that you thought you're going to get with choosing and prioritizing the questions. So that will be my advice to you guys, to start with questions that you master most. I don't know if there's anything that you want to add, Mr. Letsolo, before we get to questions, if we have any.
I think you said the mouthful, Doctor. You said the mouthful.
Thank you. Mr. Letsolo, are you still there?
I'm still here.
Okay. And I think one of the things, maybe that Letsolo, go back to where you shown us the positive and negative momentum.
Go back.
What? Yes, on the slide, yeah. I think maybe learners, one other thing that you can do, Mr. Letsolo has been emphasizing using the Cartesian plane. My advice will be draw the Cartesian plane every time where your initial motion starts. And that will make it easier for you to get the signs correct, especially when you're dealing with vectors. If on that yellow round ball that is there, if you put the Cartesian plane there, you'll see that the arrow is facing in the positive direction. And if you go to the one below the final one and you draw the Cartesian plane again there, you'll see that that PF will be in the negative direction. And that will make it much easier, especially when you then calculate whatever that you are asked to calculate and check your final answer. Your final answer, if it's not going to resemble what your Cartesian plane has shown you in terms of the directions of the vector, you must know that you have done something wrong. Then quickly go back and check where you did the wrong substitution and correct that. Thank you, Dr. Lesolo.
Thanks very much. And remember, in this case, as Dr. Paul is saying, the direction here will be the direction of velocity. Remember, momentum is mass, which is a scalar quantity, multiplied by the velocity, which is a vector quantity. So these directions we are talking about are the directions of the velocity. Okay, thanks very much. Anything on the maybe let me refer to the study guide, learners, go to the Mind the Gap study guide. You'll find a summary of the elastic and inelastic collision as I've depicted here to tell you when during collision. Remember, momentum before and momentum after is equal, but then you must be very clear about the directions, like Dr. Paul has just indicated, that put your Cartesian coordinate somewhere, the origin, it will tell you whether body number one had a positive or negative direction. There is one other thing that I wanted to play here, for example, as we are finishing off. Look at the first diagram. You'll see that the two are moving in the positive direction. The other one was at rest, but finally they are moving in the positive direction. The second one is that after collision, the small car moved in the negative direction and the truck moves in the positive direction. And the last one is the truck is moving in the negative direction and the car was moving in the positive direction. But after collision, the direction reversed. So it's very important to check what happens before and after so that you stick to the right directions. I guess, Dr. Molefe, that brings us to the end of our time.
Yeah, before that, let's go back to activity number 3 of equations of motion. There's a question on the chat that I want us to address.
Okay. Activity number 3.
This one. Okay, just go the next slide so that we summarize it very quickly.
Next, this one?
Yes, yeah, that one.
Oh, okay.
The learner was asking us to show them how to work out this problem because we left it and I tried to explain this to them. But in order to answer this learner here, remember what I said earlier, populate your data on the table.
Yes.
If you do that, it helps you to pick up the correct formula or equation that you have to use. In this instance, you'll see that you are asked to calculate the VI and you've got the delta Y, you've got the VF, you've got the G. You don't have to worry about calculating the T. It has nothing to do with this question.
Yes.
Because once you follow that route of calculating the T because you think you are smart, the likelihood of losing marks becomes very high because you'll do something that you cannot be able to show us how does it have an implication in answering this question. So take the easiest route that is straightforward from the data that you are given, then you're going to be able to collect maximum marks. That I'm not saying calculating the T first, is not going to help you to get the correct answer. You are still going to get the correct answer. But then you'll remember the activity 2 where people got the 3.06 seconds and they left it there. They're going to get half the mark. If it was a full mark, you'll get the half the mark. If it's 2 marks, you'll get 1 mark because you didn't answer the question accordingly. They wanted the complete path that the object has taken, but you gave us half the path, which is 1 segment of the motion of that particular object. So in relation to that, one might also come back here to us and say, why didn't you make delta y the subject of the formula? We are giving you the easiest way that you guys have been shown and been told that you can also do. Substitute directly on this, but look at that in relation to the previous one where we use the delta y, and you'll see that where we use the delta y to calculate making VI the subject of the formula on this one, in comparison to that of the delta Y, you'll see that it makes your life much easier in answering the questions where you are not going to get confused on now transposing the numbers, which one is going to be negative. And again, there's been the square root. You're going to take the square root of VI. You must be able to tell us why do you choose the positive or the negative in order to be able to choose which one is very correct. You might not need to state that, but if you know what you are doing, following the graphs, following the motion and what we said about the initial velocities, direction, and that of a G, you'll be able to tell that the VI must definitely be positive, not negative.
Oh,
Thank you very much.
Thank you very much, Doctor. Let's take it up to here and let's take let's go back to Dr. Masara. And thanks very much for attending. Dr. Masara will give us the closing remarks.
Before Dr. Masara, students, be advised that next week we are going to have the chemistry session that will take in place in this platform, and that will be on the 24th of May and will be presented by Dr. Suela and Nolazi for chemistry, which is part 2. Please don't miss that. And we are going to share a review the essential skills workshop video again that was presented by Dr. Fish, and the package thereof will be shared with you next week. And the replay of this live stream is on YouTube. You guys can go through that and make sure that you follow what was presented to you today for physics, and you'll do the same with that of the chemistry next week. And with all that, and thanking Mr. Letswalo for the presentation, and this is goodbye from the physics team. Thank you. Over to you, Dr. Masara.
Thank you, colleagues. Thank you, Mr. Litswalo. Thank you, Dr. Mulife. On behalf of Dr. Masala is Ndanga, the Projects Officer for South African Institute of Physics. So I would like to say that thank you very much for joining. And then we know that there are certain schools who are projecting through a screen, and then their learners were taking part of this workshop. So thank you very much for that. And I know we've got people from the department, and then we've got our colleagues from the different universities and the different science centers. And also I would like to say that we are going to also have the in-person workshops. The first one that is confirmed is the one that will be at Moipone Academy. We've got Mr. Joseph that is there on part of the participants list. So they're going to tackle the physical science topics under Dr. Mulife and then Dr. Siwela. That will be on Friday. If there's anyone who's near them, you can keep in contact with us. Then we'll make sure that you do join those in-person sections. And then, yeah, I think Dr. Mulife said a mouthful. So thank you very much, colleagues. Let's meet again on Saturday, same time. And then we are going to also share the physics booklet after this workshop. And then next week, we're going to give you also the chemistry workshop booklet after the workshop. Thank you very much, everyone. Thank you for joining.
you. And bye, colleagues and learners. Please go and study. And good luck with your exams.
Thank you, colleagues. Really appreciate what now SAIP is doing for our students, for our learners, and our communities. As one of another academics also involved with this. So really, colleagues, now this is a very good initiative, and then let's keep moving on. To you, Dr. Molefe and Tatele Tswalo, all SAIP team under the leadership of now Dr. Masara. Thumbs up, guys. And I hope the learners now will have a platform where now they could engage us outside now this forum or now in their spare times. Thanks, colleagues. Cheers, bye.
Bye-bye, everyone.
Ruela, do you want to say something? See, your video is on. Okay, goodbye. See you next time. We'll meet again next week, Saturday. Same time, same platform. Ta-da!